Okay. So this lesson is about conditional probability. So probability of one thing given that something has already happened. So these are probably dependent events, like we've talked about before. And most of the time they show you through a table, or if they don't show you through a table, you could create a table or a tree diagram. So our focus here is going to be reading tables, looking at tree diagrams, and understanding how to calculate conditional probability. So you'll see here, conditional probability is the probability that an event B will occur given that event A has already happened. So when you calculate the probability, if you look at the formula here, the formula is still a fraction formula like any probability. The difference here is that instead of saying the probability of something over the total, you're trying to find the probability of B, but you know that A already happened. So it's going to have to be in the category of A and B. And the denominator, instead of saying total like it normally does, now says the probability of A because you know that event has already occurred. So let's cut your total down. Kind of like when we were choosing cards, if they said we were choosing spades, when we were like doing the combination calculation, we didn't use 52 as our total number of cards anymore. We used 13 because we already knew it was spades. So we like lowered that total amount by the requirement. Oh, sorry. One more note about that. This bar right here is notation that something's been given. So this is probability of B given that A already happened. So in example 1 here, you see a table. It shows male and female freshmen who chose to play one of 3 intramural sports offered at college. And the question is, what is the probability that it was soccer given that it's a female? So the way we calculate this is success is going to be someone who played soccer and is a female. Total is really just going to be the number of people in the female section because we already know that it's a female. So when we look at this, to get the total female, we're going to have to add up this column, which is 113. So that's going to be our denominator. And to be soccer and a female is this number right here in the chart, which is 61. So our probability is going to be 61 out of 113, which is 0.54 or 54%. Okay. All right, so another example. So this is amount of land area and water area in square miles in certain states in the U.S. So it says, what is the probability if a point is chosen at random that it's water given that it's in Florida? So they're asking, what's the probability that you're in one of these water areas given that you're already in Florida? So according to the formula and what we understand about conditional probability, this means a success to us is the number that's in water and Florida. And the total is not everything in the chart. The total is just about Florida because we've been given that it was in Florida. Okay? So for Florida, the totals are here of land and water. So we would add those two numbers up, giving us 15, 9, 7, 65,795. And to be a water area in Florida is this 11,777 number, giving us 0.179 or 17.9% probability. All right, the last example like this that's going to give us a table. This table shows male and female customers at a cafe on a certain day. Each customer either drank soda or iced tea. What's the probability the customer drank soda given that the customer was a male? So in other words, what's the probability that they drank a soda given they were male, which means we're calculating what's the amount of soda drinkers that are male over the amount of males in this problem. So male total is going to get across this row right here. for a total of 50. And soda drinkers that are male is that cell right there, 21. So this is 21 out of 50, which is 0.42 or 42%. All right, now the last problem we're going to look at is conditional still. They're not going to give us the chart, and it's an and probability. So if we read the problem, it says the chance of rain for the next evening is 60%. If it rains, the chance of lightning is 80%. If it does not rain, the chance of lightning is 5%. What is the probability that will not rain and there will be no lightning? So let me first say, okay, we're trying to calculate the probability of no rain and no lightning. So we know from the past we can multiply those two probabilities together because it's an and problem. Okay? So first we want to find out what the probability of no rain is. Okay? And there will be no lightning. Now this part depended on the first part. So the probability here is no lightning. But that's already given that there's no rain. Okay? So I need these two numbers to multiply together, and then I can figure out my probability. So I'm going to use a tree to help me. So a tree helps me when it's like I have two options, and then with either of those options, I have another two options that are similar. So for example, here, it could rain, or it could not rain. But in either of those cases, the second thing we looked at is if there was lightning, or if there was no lightning. So this is when a tree is useful, similar choices, like so. Then what we can do is put the probabilities along the branches of the tree to kind of model what's happening. So the first decision that's made is it going to rain or not rain? So the probability of rain was 60%. That means the probability it's not going to rain is 40%. So they add up to 100%. It's either going to rain or not rain. Then at each case, so here once it's rained, lightning or no lightning. So it said if it rains, the chance of lightning is 80%, which means the chance there will not be lightning is 20%. If it doesn't rain, so if you're over here in this situation, the chance of lightning is 5%, which means the chance that there isn't lightning would be 95%. Now you can see exactly what they're asking us. The probability that there's no rain and no lightning can be viewed in this branch right here, no lightning resulting from no rain. So it's this path right here. So the probability that it's not rain is 0.4%. The probability that there's no lightning given that there's no rain is this 0.95%. Not this other one because it was on the raining branch. Now when we multiply the two probabilities together, we get 0.38 or 38%. So this should help you guys with homework.